So, what if your software documentation literally wrote itself? I mean, what if it updated in real time with every single code change, making the word outdated totally obsolete? Well, that's the promise of autonomous agent swarms. And today, we're going to break down exactly how they're flipping the world of software development on its head. Let's dive in. This quote right here really just nails the ambition. We're not just talking about faster documentation. The goal is a system so incredibly seamless that the line between a code change, its documentation, and customer support, well, it just completely vanishes. Okay, so what's the big problem this whole new approach is trying to solve? It's a crisis that pretty much every modern software company is dealing with, and it's called doc lag. Think about it. In today's world of rapid-fire deployments, a manual can be out of date the very same day it's published. This creates this nasty, hidden cost called support debt. And it's a vicious cycle, right? Your support team is left trying to put out fires with old information, which frustrates your users, which then pulls your most talented and expensive developers away from building new things just to answer basic questions the docs should have covered in the first place. So the solution is to just stop treating documentation like this separate manual chore. Instead, we can think of it as a living, breathing byproduct of the code itself, something that's generated and updated automatically by an autonomous swarm. So what exactly is a decentralized swarm in this context? Well, you can imagine it as a team of highly specialized AI agents. Each one has a very specific job, and they all work together. They're constantly watching for code changes and updating everything from user guides to support articles in real time, all without a human having to lift a finger. But you might be wondering, how do you get a whole team of independent agents to work together without it just becoming total chaos? Well, the secret, it's all in the system's architecture. Let's take a look under the hood. At the very heart of this system is something called the Blackboard architecture. The best way to think of it is like a shared digital workspace or a central command center. When one agent, let's say the watcher, spots a code change, it doesn't shout out to the other agents directly. No, instead, it posts the details, the what, where, and why of the change to this shared space. Other agents, like the Chronicler, are basically subscribed to these updates and can immediately grab that data to do their own job. It's a really simple but super powerful way to make sure every agent is on the same page, working with the latest info without ever tripping over each other. And here's the team itself. You've got the watcher, who's like the scout, constantly scanning GitHub for new code. Once it finds something, the Chronicler, who is basically the team's scribe, gets to work drafting the new docs. Then the verification agent comes in to act as the fact-checker, and finally, the support agent is your first responder, always armed with the latest, fully verified information. Now, this is a really crucial point. Why go to all this trouble with a team of specialists instead of just using one giant generalist AI? Well, a single large model trying to do everything at once, analyze code, write docs, test APIs, is just way more likely to make mistakes and come up with hallucinated instructions. But by having specialized agents like a chronicler that is an expert at technical writing, the quality and the accuracy of the final output are just so much higher. Okay, so we've seen the architecture, we've met the team. Now let's see how it all comes together in a real-world scenario, starting from the exact moment a developer commits brand new code. Just look at the speed here. It's wild. A developer pushes code, and literally 1 second later, the watcher has already flagged it on the Blackboard. And then, within 10 seconds, just 10, the documentation is not only written, but it's also been tested against live APIs and fed directly into the support system. This entire loop is finished before a user could even begin to type out a question. Now, I know what you might be thinking. A 10-second fully autonomous process? That sounds a little risky, doesn't it? What if the AI messes something up? That's a totally fair question, and the system actually has a pretty elegant answer for it. And here it is, the human-in-the-loop safety switch. Before any change actually goes live, a human expert gets a quick 10-second window to glance over the proposed update and just give it a final thumbs up. It's really the perfect blend of autonomous speed and human oversight. So what does all of this speed, accuracy, and automation actually give you? Well, it delivers something called the zero-day advantage. This is the ultimate goal right here, zero. Zero time between a feature being released and your documentation being perfectly ready to go. That knowledge gap that plagues almost every single software launch is just completely eliminated. And you know, the results really speak for themselves. This data shows the impact on how many support tickets have to be escalated. Before the swarm, a ton of tickets had to get kicked up to developers. But after implementing the swarm, that number just plummets because the first line of support already has the correct up to the second answers. This is the ultimate competitive edge. I mean, imagine a support bot that's as knowledgeable as your very best developer. Because it's pulling information directly from that verified source of truth, the Blackboard, it can give customers perfect code snippets that match the exact software version they're using. That is a level of support that was pretty much unimaginable until now. So what's next? Well, the really big picture vision is for self-healing software. A future where the swarm doesn't just document changes, but it actively spots user problems and friction points, and then suggests code fixes right back to the dev team, creating this fully autonomous loop of continuous improvement. A pretty wild thought to end on, isn't it?